At the point when this sort of mayhem drives it out into the virus dark profundities of intergalactic space, then again planets could be ousted from their circles, slam into each other, or even influence their host stars because of these gravitational aggravations. When gas and residue are compacted under very high tension, gravitational reworking can really cause new heavenly bodies to shape or maybe begin stars to arise. In our solar framework, the late weighty barrage proposes that around for quite some time prior, there was a time of expanded impacts including comets and space rocks. This flood in effect is accepted to have come about because of attractive energy unsettling influences brought about by the outer planets. During this turbulent stage, gas monster science like Jupiter and Saturn were going through relocation, upsetting the circles of various more modest bodies in the Kuiper belt and space rock belt. As an outcome, these more modest items were tossed into capricious ways, with many making their way into the inward nearby planet group. This deluge prompted a critical ascent in influences on the earthbound planets, including Earth. While these impacts didn't include direct conflicts between planets, they show how gravitational associations can bring about significant changes in the directions of divine bodies. This barrage is remembered to have played a vital job in molding the surfaces and topographical narratives of planets in our planetary group. Furthermore, it might have added to the conveyance of water and natural materials to Earth, affecting the improvement of our planet over an extended period. As stars go through changes in mass streams, then pieces of planets around them might wind and possibly cross. This is particularly noticeable in frameworks where stars are at the finish of their life cycle. As a star ages and consumes its atomic fuel, it frequently goes through huge mass changes, particularly during stages like the Red Goliath stage or when it discharges material in a planetary cloud. These varieties in heavenly mass can essentially influence the gravitational equilibrium of the framework, causing the circles of neighboring planets to either move outward or, on the other hand, become more packed. This is more prone to occur in multi-star frameworks, where complex gravitational collaborations can without much of a stretch lead to temperamental circles. In such frameworks, the gravitational powers from various stars can interact eccentrically, fueling orbital shift, and expanding the possibilities of circles converging. This can result in circumstances where planets could get caught by another star, slam into other heavenly bodies, or even get shot out into interstellar space. Pluto's extraordinary circle, initially recognized as an undeniable individual from the planetary family, went through a renaming, eventually being assigned as a bantam planet inferable from its particular circle. The astronomy local area is as yet excited by it and finds it interesting even with this change. There's reason to worry concerning the closeness of Pluto's parcel to Neptune's. As indicated by later gauges made by famous researchers like Neil deGrasse Tyson and Mitaka Kaku, these researchers are sounding the alert about a grave danger to Earth. The plausibility of a crash between the planets Pluto is not normal for some other planet in our planetary group, and this is what makes its circle around the Sun so unique. Pluto is far away from the Sun, of course, so the Sun is multiple times fainter than it is here on the planet. So its freezing temperatures decrease to around -230 degrees Celsius during the evening time. In an intensity wave, you could get as high as 170 degrees Celsius. It has an exceptionally shaky climate too. Welcome, inquisitive personalities, to an investigation past the natural domains of our solar system. Imagine a scenario where I let you know that Pluto, the far-off and cryptic bantam planet, is at long last taking its enormous action, possibly crashing into none other than Neptune, the ice monster. Pluto's defiant nature has been apparent from the starting, a rebel on the edges of our heavenly area. Its circle boldly encountering another planet challenges the traditional standards of planetary conduct. I imply that is no sort of direct for a planet right from the confounding complexities of Pluto's circle to the raised worries voiced by astrophysical illuminators like Tyson and Kaku. A waiting inquiry hangs in the vast equilibrium. Will these heavenly Goliaths take part in a crash course? Could the assembly of their ways spell unexpected ramifications for our dearest planet Earth? Today we set out on a grandiose excursion loaded up with vulnerability. While the responses to these heavenly inquiries might evade us right now, the potential for a crash of such enormous extent fills in as a distinct update that the universe is a phase for occasions both inspiring and perhaps frightening. Go along with us as we dive into the secrets that circle our comprehension of Pluto and Neptune, mulling over the conceivable outcomes of a divine conflict that could reshape the inestimable equilibrium of our nearby planet group. The stage is set, and the unfurling show coaxes us to witness the mysterious dance of the planets, among other potential space catastrophes. The universe harbors a variety of riddles, and among them is the multifaceted riddle known as the three-body issue. Yet, researchers anticipate other expected upheavals inside the heavenly theater. Albeit a planet crashing into one more in space is profoundly far-fetched, it isn't absolutely out of the inquiry. Gravitational communications, as depicted by the three-body issue, are one of the powers that influence planet circles. An illustration of a space framework where gravitational powers produce an intermittent example known as orbital resonances is TRAPPIST-1, which has 7 planets the size of Earth. As time elapses, these examples could debilitate planet circles, improving the probability of crashes. What is going on does exclude any crashes, despite the fact that frameworks, for example TRAPPIST-1, are very thick and planets influence one another's courses, particularly when they are close. Researchers routinely screen these frameworks to grasp this. With this data, we can all the more likely grasp how the planets travel through space. Another obscure realized part is maverick planets, which drift carelessly in space rather than encircle around a star. Removal of planets from star frameworks can happen as a consequence of gravitational shafts or other cosmic peculiarities. For example, another star's nearby methodology or dynamic shakiness in frameworks with more than one planet. Over the long haul, these wandering planets can travel perfect removes, potentially in any event, arriving at regions a long way from where they started. It is conceivable that they will run into other star frameworks on their performance journey. The probability of a planet impact increments on the off chance that one of these planets goes to another planetary group. Regardless, a rebel planet striking another planet head-on is very improbable, taking into account how huge and generally unfilled space is. The sparsity of planets in open space and the enormity of interstellar distances cooperate to deter incessant impacts. It is, as of now, exceptionally improbable that 2 rebel planets will impact. Yet, the recurrence of rebel planets is far lower than that of stars also, and planets in stable circles. The star frameworks included can become tumultuous in the occasion of a cosmic consolidation. It is profoundly improbable that planets will impact head-on during these enormous occasions due to the tremendous interstellar distances. The circles of stars and planets within emerging cosmic systems are modified decisively by regions of strength for the gravitational powers. A planet might turn into a rebel world liberated from any star. A circular shape, the secret developed with the acknowledgement that Pluto's circle crosses that of Neptune. The three-body issue Pluto's circle stays stable in the midst of the complexities, filling in as a demonstration of the intrinsic intricacies of heavenly mechanics. Appreciating the movement and gravitational collaborations of 3 great bodies like Pluto, Neptune, and the Sun is known as the three-body issue in space. Predicting their directions from their beginning positions and the impacts of gravity on each other is comparative. For Pluto, some of the terms that assist us to settle this galactic secret are ASM libration, scope libration, and the VZK wavering. As per astrophysicists, AMU libration is critical on the grounds that it keeps planets in their circles. When Pluto crosses Neptune's circle, it is no less than 90 degrees far off, which is a critical distance that forestalls impacts. As indicated by this definition applied to Pluto and Neptune, scope libration, alluding to the upward development of a heavenly body in its circle, ensures that when Pluto approaches Neptune or other giant planets, it is arranged altogether over their orbital plane, giving an extra layer of insurance against crashes. A key element in understanding heavenly movement is the VZK wavering, named after 3 scientists, Van Lee and Kai. They investigated the gravitational collaborations between 3 space objects, for example, Pluto, Neptune, and the Sun. The VZK wavering makes sense of why Pluto's circle around the Sun seems uncommon but stays smooth over the long run. Notwithstanding the evident irregularity in space, basic examples and rules keep everything under control. These factors, all things considered, settle Pluto's circle, forestalling impacts with Neptune or deviations from its course. The three-body issue assists us with understanding how the gravitational PS of these space objects impact their way. Considering this adds, as far as anyone is concerned, of Pluto, our planetary group, and far-off heavenly bodies. Mathematical reenactments in the last part of the 1980s uncovered that, despite stable properties, Pluto's circle is actually turbulent, with minor introductory deviations prompting huge contrasts north of millions of years. Circle dependability notwithstanding, Pluto's exceptional circle shows striking dependability over broad periods, truly moderating expected mayhem. Late virtual experiences have extended our perception of the many-sided elements, including enormous planets like Neptune, Jupiter, and Saturn, impacting Pluto's direction around the Sun. Neptune's particular gravitational impact, finishing 3 circles for each 2 of Pluto, essentially adds to the generally speaking solidness of Pluto's orbital way. Jupiter's gravity is similarly significant, however less so than Saturn's. Taken as an entire, this large number of observations illustrate that Pluto is in secure and consistent movement across space more than billions of years. It is ensured by the joined impact of Jupiter, Saturn, and Neptune to keep the movements of divine bodies in the universe requested and unsurprising. These events are fundamental. In the non-attendance of these frameworks, the solar framework would be more turbulent and capricious, improving the probability of crashes and discharges from generally consistent courses, which may have extensive ramifications for other divine bodies. Considering later theory with respect to an inevitable impact among Pluto and Neptune, it is fundamental to fathom Pluto's circle. With this data, the ever-changing planetary group might be better gotten a handle on. The instance of Pluto shows how the complex connection between orbital mechanics and gravitational powers may make clearly unsound circles accomplish balance. To more readily comprehend our spot in the universe, it is pivotal to ceaselessly notice and investigate these occasions. Space investigation habitually uncovered the unpredictable way of behaving of eminent bodies. Pluto's circle is the exemplary outline of this unpredictable conduct. The case of Pluto gives a striking outline of the possibility of orbital confusion, which shows how the direction of a divine body is exceptionally reliant upon its beginning stage. Minor changes in the Bantam planet's area or speed can hugely affect its orbital way. Long-term researchers' comprehension of Pluto's movement in space is generally due to programmatic experiences to recreate the gravitational connections among Pluto and other planetary bodies like Neptune. These reenactments utilize unpredictable numerical models. Stargazers can perceive how little changes can altogether influence Pluto's way by controlling the models. These models revealed an entrancing piece of Pluto's direction in the last part of the 80s. The circle of Pluto can in any case be somewhat eccentric, despite the fact that it is settled by highlights like AIML and scope libration. When Pluto's situation or speed is to some degree off from the begin, it can change its direction significantly throughout a few years. Even while Pluto's circle is innately tumultuous, it stays stable for an extremely lengthy timespan, billion particles of years. This proposes that underneath its apparently unpredictable appearance, Pluto's excursion around the Sun follows an organized request, anticipating enormous occasions. Particularly with planets like Pluto that have eccentric circles is very testing. The intrinsic eccentricism of these frameworks makes long-haul figures dubious. Mathematical reenactments assist us with understanding and expect the future ways of heavenly bodies, yet they likewise uncover the cutoff points of our prescient capacities. These models intensely rely upon exact introductory conditions and at complex communications. Indeed, even a little blunder can prompt essentially various results, making exact expectations troublesome. The tumultuous nature of divine circles, such as Pluto, helps us to remember the ever-changing universe. While we've gained ground in understanding space, Pluto's case highlights our continuous restricted information. Understanding the gravitational impacts of monster planets on Pluto's circle gives important experiences into the more extensive elements of the nearby planet group. It exhibits how every planet's presence and position can influence the dependability and direction of different bodies in the framework. Concerns of an expected impact among Pluto and Neptune, while captivating, are generally unwarranted based on our ongoing comprehension of divine mechanics. The stability of Pluto's circle, represented by complex gravitational associations with other planets, guarantees that such an occasion is exceptionally far-fetched. The dance of divine bodies in our nearby planet group, including Pluto and Neptune, is governed by many-sided gravitational forces and orbital elements. While the chance of a crash between these far-off planets flashes interest and theory, The crucial stability of their circles, maintained by the laws of physics, mitigates such worries. Through continuous perception, examination, and mathematical recreations, researchers proceed to expand how they might interpret Pluto's novel excursion through space, shedding light on the more extensive secrets of our dynamic universe.